Decibels. The volume of a sound is measured in decibels, given the abbreviation lowercase d, uppercase b. The bell is from Alexander Graham Bell. The deci is as 10 bells is the smallest change in volume that is noticeable. 0 decibels is what is called the threshold of human hearing, the lowest sound a human could hear, and this has an intensity of 10 to the minus 12 watts per square metre. A 3 decibel increase doubles the power of the sound, or the intensity. A 10 decibel increase makes a sound of 10 times the power. Here we have some examples, with a rock concert at the front row being 110 decibels, and at the back row 100 decibels. This means at the front row of the rock concert you'll be exposed to 10 times the intensity as someone at the back. A factory has 100,000 times, which is 10 to the power 5 times the intensity of the sound as a library, as a factory is on 90 decibels, which is 50 decibels, or 50 lots of 10 times the intensity of a library at 40 decibels. Here we have what are called curves of equal loudness. These lines show sounds that would appear to be the same volume, even though they're not. So for example here we have 1000 Hz and a volume of 20 decibels. At 100 Hz we would need around 50 decibels to sound the same volume. On the right hand side we have the phon scale. If a given sound is perceived to be as loud as a 60 decibel sound at 1000 Hz, that's 1000 Hz and 60 decibels, this point here, it is said to have a loudness of 60 phons. So 60 phons simply means as loud as a 60 decibel 1000 Hz tone. So right along here we have 60 phons, which you'll see around this point equates to 110 decibels. You'll notice all the curves of equal loudness dip along this line. This shows the maximum sensitivity of the ear is around 3 to 4 kHz, and this is due to resonance within the auditory canal. The ear is less sensitive to low frequencies, and the sensitivity drops off faster for softer notes, so these lower lines of equal loudness rise rapidly along here. We need a much louder sound to sound the same, whereas this higher volume sound is much more horizontal. The quality of the sound you hear also depends on the condition of your ears, and this can be affected by continuous exposure to loud noise.